In this video, we will discuss what is welding defect. So here you can see the two plates, they are joined together with the welding process, and this is your welded, this is known as weld metal, and the area near the weld metal is known as heat affected zone. So if the defect occur here, then the defect is known as welding defect. So what is welding defect? So the welding defect can be defined as the irregularities formed in the given weld metal due to wrong welding process or incorrect welding pattern. So basically the welding defect occurs due to the wrong welding processes or incorrect welding pattern. The defect may differ from the desired weld bead shape, size and intended quality. So if the defect occur due to which what happen, we will be not getting a desired shape and size of the weld bead, or we are not getting a desired quality of the weld bead. Welding defect may occur either outside or inside the weld metal. Some of the defect may be allowed if the defects are under permissible limit, but other defects such as crack are never accepted. So few defects that you can accept it within some limit, but the defects like crack that are not acceptable because that leads to failure of that component. So this is the welding defect. Now the classification of welding defect. So you can classify the welding defect in two categories, that is external welding defect and internal welding defect. Now the external welding defect, these are weld crack, undercut, spatter, porosity, overlap, crater. Whereas internal welding defect, that is slag inclusion, incomplete fusion, necklace cracking, incomplete penetration. Now we will see this defect in details. So the very first defect, that is weld crack. This is most unwanted defect of all other welding defect. Welding cracks can be present at the surface, inside the weld material or in the heat affected zone. So here you can see the crack. So this crack may appear in the weld metal or in the heat affected zone. So this is your heat affected zone. So this crack may appear in the weld metal or in the heat affected zone. Here you can see the actual crack which is present in the weld metal. So such type of crack is known as weld crack. Now what are the causes of weld crack? Number one, poor ductility of the given base metal. So whatever parent metal that you are welding, if it is having poor ductility, that may be the cause. The presence of residual stresses can cause the crack on the weld metal. So after joining the two plates together, then there is a solidification of the weld metal, and due to which the residual stresses may occur, and that is a possible cause for the weld crack. Then the rigidity of the joint, which make it difficult to expand or contract the metal. So if your joint is very rigid, then during solidification the metal tries to contract or some metal tries to expand. So in that case, the rigidity of the joint, it makes it difficult to expand or contract the metal. Then if there is high content on sulfur and carbon, then also the crack may occur. Then using hydrogen as a shielding gas while welding ferrous metal. So these are the possible causes of weld crack. Remedies: using appropriate material may decrease the chances of crack. So if your material is having enough ductility, so using appropriate material. Then preheating the weld and reducing the cooling speed joint help in reducing the crack. So preheating is one of the process. So before welding we preheat the material. So that is nothing but preheating, and then reducing the cooling speed. Then reduce the gap between the weld joint by using reasonable weld joint. So the gap should be properly maintained in between two plates. Then while welding, releases the clamping force slowly, which increases fill to capacity of welding material. So while performing the welding, if we release the clamping forces slowly, then also that will reduces the residual stresses. So these are the possible remedies for weld crack. Now the second welding defect, that is undercut. So when the base metal melts away from the weld zone, then the groove is formed in shape of notch. Then this type of defect is known as undercut. So here you can see the undercut. Okay, here you can see the groove. This is nothing but your groove. So this is known as undercut. it reduces the fatigue strength of the joint. So here also you can see this is your undercut. Okay, so this is your weld metal and these are the two plates. They are joined together and here the weld metal is not reach. So this is an example of undercut. Now what are the causes? If the arc voltage is very high, then this defect may occur. So basically in fusion welding, the arc is generated in between electrode and the base material. So if this arc voltage is very high, so that may be the cause. Then if we use wrong electrode or if the angle of electrode is wrong, then this defect may also form. Okay, so selection of electrode, that is also very important. Using a large electrode is not advisable. So diameter of electrode, that is also very important. High electrode speed is one of the reason for this defect, and the welding speed. So these are the possible causes for the undercut. Then remedies. Reduce the arc length or lower the arc voltage. Then keep the electrode angle from 30 to 45 degree with the standing leg. Then the diameter of the electrode should be small. Reduce the travel speed. These are the remedies. Then the third defect, that is known as spatter. So when some of the metal drops are expelled from the weld and remain stuck to the surface, then this defect is known as spatter. So here you can see the spatter and this is the actual image. So the metal droplets, they get deposited over the parent metal, that is known as spatter. So this defect is known as spatter. Now causes: high welding current, then longer the arc, more chances of getting this defect. So arc length, that should be carefully chosen. Arc length is nothing but the distance between the electrode tip and your substrate or the parent metal. So that arc length should be carefully chosen. Incorrect polarity. So if you are using DC, then there are two types of polarity, that is straight polarity and reverse polarity. In straight polarity, we connect negative terminal to the electrode and positive terminal to the workpiece, whereas in reverse polarity, we connect positive terminal to the electrode and negative terminal to the workpiece. So this polarity must be carefully chosen. Then improper gas shielded may also cause this defect. So shielding, that should be proper. Now remedies: reducing the arc length, using right polarity and according to the condition of welding, increasing the plate angle and using proper gas shielding. The fourth defect, that is known as porosity. So porosity is the condition in which the gas or small bubble gets trapped in the welding zone. So here you can see the porosity. So what happened? The small bubble or the gases gets trapped in the welded zone. So here you can see the actual porosity. Here you can see the blowholes in the weld. So this is known as porosity. Why it is happening? Because of the gas bubble that is get trapped inside the weld, and that is why there is a formation of pores, that is known as porosity. So what are the causes? It occurs when the electrode is not coated properly. So if you are using shielded metal arc welding process, so the electrode is coated with the flux, and if it is not properly coated with the flux, then it is not able to provide the proper shielding, and that is why the porosity may occur. Using a larger arc may also increase its chances. So if the arc is more, in that case also there will not be a proper shielding. Increasing welding current, then rust or oil on the welded surface. So before welding, you have to clean the surface. If there is a rust or oil, suppose there is a oil on the weld surface on the parent metal, and then you are performing welding, in that case that oil get evaporate and that forms the bubble. Remedies: proper selection of electrode, decreasing the welding current, using smaller arc, slowing the process, removing the rust or oil from the surface. Then fifth defect, that is overlap. When the weld face extend beyond the weld toe, then this defect occur. In this condition, the weld metal rolls and forms an angle less than 90 degree. So with this figure you can understand overlap. Here you can see the molten metal gets overlap. Okay, this is the extra molten metal. So this is known as overlap. So here also you can see this is your overlap. Here there is the extra weld metal. So this is known as overlap. Now what are the causes? Improper welding technique, then by using large electrode and high welding current. Remedies are using proper technique, use small electrode and less welding current. The sixth external defect, that is crater. It occurs when the crater is not filled before the arc is broken, which causes the outer edge to cool faster than the crater. This causes a stress and the crack is formed. What are the causes? Incorrect torch angle, use of large electrode, improper welding technique. Remedies are using proper torch angle, using small electrode and use proper technique. So these are all 6 external welding defect. Now we will discuss internal welding defect. So the first internal welding defect, that is slag inclusion. So if there is any slag in the weld, then it affects the toughness and weldability of the given material. So here you can see this is your slag and it is get entrapped into the weld metal. So if there is any slag in the weld, then it affects the toughness and the weldability of the given metal. This decreases the structural performance of the weld material. Then slag is formed on the surface of the weld or between the welding turns. So suppose you are performing the welding in number of passes, then there may be a chances that the slag may get entrapped in between 2 passes. So that is known as slag inclusion. So here also you can see this is the slag. Now what are the causes? Slag is formed if the welding current density is very small, as it does not provide the required amount of heat for melting the metal surface. So if your welding current density is less, in that case there is a formation of slag. If the welding speed is too fast, then also slag may occur. Then if the edge of the weld surface is not cleaned properly, and then improper welding angle and travel rate of welding rod. So these are the possible causes for slag. Remedies: increase the current density, then adjust the welding speed, clean the edges, and then have proper electrode angle and travel rate. So these are the remedies. Now second internal defect, that is incomplete fusion. So here you can see the incomplete fusion. Your weld metal is not reached to this area. This is the cavity form. So this is known as incomplete fusion. So incomplete fusion occurs when the weld does not accurately weld the material and the metal are pre-solidifies, which leads to a gap which is not filled with the molten metal. So here the gap is formed and it is not filled with the molten metal. Hence it is known as incomplete fusion. So this is an example of your incomplete fusion in the real life. Now it occurs because of low heat input. So that is the first cause, that is low heat input. What is heat input? So if you multiply current into voltage divided by welding speed, that will give your heat input. Then when the weld pool is very large and runs ahead of the arc. So the weld pool which is going to form is very large and it is runs ahead of the arc. Then when the angle of the joint is too low, then incorrect electrode and torch angle, and then improper bead position. So these are the possible causes. Remedies: increase the welding current, decrease the travel speed. Second, reducing the deposition rate. Then increasing the joint angle. Then try to position the electrode and torch angle properly so that edges of the pelt melt away. And then positioning the bead properly so that sharp edge with other bead can be avoided. So these are some remedies. The last defect, that is known as incomplete penetration. So this defect occur only in the butt weld where the groove of the metal is not filled completely. So here you can see the groove, it is not filled completely. The cavity is not filled completely. Hence it is known as incomplete penetration. It occurs in butt joint only. Butt joint means if you are placing 2 plates aligning each other, then that is the joint form is known as butt joint, and this defect occur in the butt joint. It is also called as incomplete penetration effect. So here you can see, okay, This is the incomplete penetration. Metal is not completely penetrated. Now causes less deposition of the weld metal. So if you have deposited less metal, then use of improper size of electrode. If the size of electrode is not proper, then improper welding technique. So you have to work on your welding technique also. Remedies: more deposition of the weld metal. You have to deposit more metal. Then use of proper size of electrode and use of proper welding technique. So these are the welding defects. Thank you so much for watching this video. Thank you.